Yata she Kayla Foster Yanusha, Kia Ani Nishle, Kazarache Bashashin, Kinsachini Dashache, Ia Kini Dashanele. Hi, my name is Kayla Foster, and I am an individual of these four clans. I am the Towering House people born for the Red Goat clan. My paternal grandfather is the Red House clan, and my paternal grandfather is the Cliff House people. And today I will be talking about unlocking potential, promoting diversity through soil health in young orchards. When I was a child, one of my fondest summerhood memories was when my family had peach trees in front of their house. I would help my grandmother make peach cobbler every summer. And unfortunately, due to the heavy drought and rainfall that hit my community, majority of our trees have died or their production has just stopped completely. So what does a peach tree have to do with young orchards? Well, through the RECCS program, I was able to work with the Boulder Apple Tree Project, and they have three main goals: the preservation of apple varieties in the Boulder and Colorado area, a community involvement towards science education, and the area I'm working in was promoting agroecosystems by increasing diversity and ecosystem services in orchards. So biodiversity is the diversity of life, specifically in areas of the number of species in an area, genetic diversity, and the diversity of functions within a system. Biodiversity is directly linked to ecosystem services, which are essential benefits that both directly and indirectly affect us in various ways. While there are a lot of forms of ecosystem services, I'll be focusing on regulating services, specifically water holding capacity and organic matter content in soil. So, due to increased levels of CO2 in the atmosphere, it has led to an increase in the temperature globally. This has created unusual weather inflections such as drought, extreme thunderstorms to the point to where we have flash flooding damage, which ultimately leads to soil erosion, which is the damage to the top layer of soil, removing essential elements needed. This can actually affect ecosystem services by reducing crop production, along with water intake and overall tree health. So that led me to my research question. Does functional diversity of plants influence soil health, such as water holding capacity and organic content matter? During my time at the Boulder Apple Tree Project, I was working with an experimental orchard on the north side of Boulder that was established in 2023. These plants have understory plants that will eventually live underneath each tree's canopy. And this orchard is home to 32 different apple varieties. So what I did was around each tree, there are 4 quadrants that I actually got 2 samples from, collecting in a total of 64 samples. To also get a local comparison of untreated soil, we actually got 5 samples from an area called Cottonwood Degraded Prairie, and another area in red, which is Belgrove Degraded Prairie, and we got 5 samples there. To test the water holding capacity, we actually got those samples, placed them in tin, and soaked them in water overnight. The next day, the water soaked soil is then weighed and baked for 3 days at a temperature of around 50 degrees Celsius. This allows adequate time for the soil to completely dry before it's reweighed again, and the water holding content is then calculated. Before I go through the results, I kind of want to go over the graph a little bit. So on the x-axis, we have the different understories within the orchard, and at the very end is the degraded prairie control, which are the areas that are outside of the orchard. The y-axis is the water holding capacity. So what we noticed was that the pollinator understory within the orchard actually had the highest values. And the highest value for the orchard in total was around 0.76 to 0.86 water holding capacity. And we also noticed that the degraded prairie orchard, the degraded prairie area, was actually 9.3% lower than the overall orchard values that we found. So for the organic matter content, how we calculated that was we would weigh each type of soil at least to 1 to 2 grams. Those soil samples were then baked for 4 hours at 550 degrees Celsius. And then this is to ensure that all the essential nutrients in these soils are baked out. Once they're cooled, they're actually reweighed, and then we find the difference in organic matter lost through that. So the graph is about the same as the water holding capacity. The understory health is on the x-axis, and the total organic matter loss in percentage is on the y-axis. What we found is that the pollinator understory actually has the largest mean of total organic matter at 0.01. However, we did notice that the degraded prairie control was 20% higher than anything out of the orchard. So in our conclusion, we actually find that the pollinator understory yielded the largest mean in water holding capacity and total organic matter. This helps show that the pollinator understory in the trees is an important contributor to the ecosystem's diversity. They not only attracted pollinators to the area, but it also enhanced soil health, unlocking its potential. The future work for this orchard is that this orchard is still in its beginning phases of life. The data that I gathered this summer will be compiled for future comparisons in the field. And by examining this data, we want to show how soil diversity, specifically using plants to help create increased resilience and resistance in climate events in the future. Hopefully this information can be used by future orchardists to create more sustainable apple orchards using understory plants that can influence the soil's health. I just wanted to take some time to do some acknowledgements. Thank you to Sarah Elizabeth, my mentor, for guiding me through this research experience. My immense gratitude to Amy and Carla for their help with my posts and presentation. To my fellow Boulder Apple Tree Project interns, Nix and Maddie, for their incredible help and their company throughout the summer at the orchard. To the RECCS team for this opportunity, my fellow RECCS interns for their relatable experiences throughout this program, and my endless gratitude to my family, partner, and friends, who I couldn't have done this without their support. Thank you.
Questions for Kayla?
Yes.
Kayla, what depth did you collect the soil?
We normally try to keep it around 10 to 17 centimeters. However, with the dry season that we had this summer, it was really difficult sometimes to get in between that. So some of the values had like maybe 9 centimeters or 7 centimeters at most.
I assume that the using the degraded prairie as control is because where the orchard was degraded prairie prior to the
Yes,
project.
it was. So we wanted to see if there was any changes within that small amount of time that we had established that orchard, just to see if we could possibly make a divergence to the point to where we meet the same amount as the total organic matter within the prairie. But hopefully our plan is that the orchard will continue to climb as the degraded prairie plateaus.
Follow to that, the pollinators, were those planted purposely or are those just naturally?
Everything in the orchard within the understory plants were planted purposely to see if we could see any differences within, like, let's say the pollinators did better, the understory soil health, and to see which tree was thriving based on the plants underneath them. Yeah.
I'm curious what plants were planted in the understory, and it seems like you're kind of saying that was probably the mechanism for like increased water.
So some of the plants were Monarda fistulata. Some of them were other Butella plants, Cytodes grama, catgrass. Different types of plants were used, so mainly grasses and some flowers, just to give us a little bit of both. And that's the reason why we think the pollinator did so well, is because some of the flowers actually had deep roots set in, and some of those flowers naturally release nitrogen into the soil. So that was one of the interesting things that we saw.
Oh, yes. Thank you so much.
Thank you.